Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, Magnetism. Today we are entering into the session number 2. So far we completed one session on magnetism, that is last Tuesday. So where we learned about the history of magnetism. What is the history of magnetism? Means when the magnetism is started, how it is started, where it is started, why the name is given for that material as a magnet, right? So all these three we learned, where we can say that the magnetism is property started long back, around 200 BC, before Christ, means around 2000 plus years back. So whenever a shepherd, I'll show you the picture for that also. So where exactly the property of magnetism started. So this is the real situation happens, right? What we discussed history in the last class, everything is shown here clearly. See, he is a shepherd named as Magdalena. Just a minute. Right. So he is a shepherd here. So his name is Magdalena. And this is the sheeps. You know, there are a group of sheeps are there. And this place name is Magnesia. Right. So when he is walking for feeding his sheep, see, this is one stone. See, stick is there, stick. The stick is attracted. At the bottom of the stick, there is a metal cap is there. And this metal cap is attracted by this material, which is called magnetite. That is a ore of iron, which is Fe3O4 chemical formula. See, this is complete picture explains you about the history of magnetism. When the shepherd named Magdalena walking on the place called Magnesia, right, along with a group of his sheep, his stick is attracted by a material called magnetite. And this stone is taken by the sheep and given to the experts that time, the Greek philosophers, is given to Greek philosophers. Right. Then they started studying about the stone. And this stone is identified as a magnetite, which is the ore of magnet, from which iron can be attracted. Ore of iron. It is a ore of iron, from which you can attract iron also. And later studies, after studying the properties and all, this magnetite is also named as lodestone or a magnet. So lodestone is a Greek word, which means lode means leads. Leads, stone means way. Leads the way. As you all know that magnet always shows north and south direction. Wherever you suspend the magnet, it always comes to rest towards north and south. Such property is called directional property, right? So because it shows the specific direction, it is also known as lodestone and further named as magnet. Right? So this entire picture clearly shows us the history of magnetism or prehistory of magnetism, in call it as. See how accidentally discovered. It's already there in nature, but is discovered by a shepherd. Discovered by a shepherd named as Mangalina. Because his name is Mangalina, place is Magnesia, the ore of iron is magnetite. That material is named as magnet. And the property of the material is called magnetism. Magnet is a material, magnetism is the property. Right? Clear? It's a complete picture of the history of the magnetism. So before going for the next continuation, I'll show you one video on the history of magnetism. Okay, just keep watching the screen to know more about the magnetic history, right?
Forces have been known about for a very long time. According to Greek legend, magnetism was first discovered by a shepherd when his feet suddenly stuck to the ground. The iron nails in his sandals had become attracted to a magnetic rock. This curious stone became known as magnetite, after magnesia, where it was found. But it was also known as lodestone and was highly prized because of its attractive properties. In ancient Egypt, magnetic repulsion was used to play tricks.
And nothing up my other sleeve. Ha! Ha! Hey! Ha!
Objects of worship were made to float in mid-air by the use of carefully placed magnets.
Goes right across.
The first emperor of China used magnetic forces to protect his palace. Legend has it that the gates were made from lodestone.
Lodestone!
Gates also.
On! Come on! Outrageous. Is that his bottom? What? He's invading his...
Attacking enemies wearing iron armour were completely flummoxed when they were instantly attracted to the gate and got no further. And this is a small lump of lodestone. Like any metal ore, it's found in the ground. The scanner reveals its natural magnetic field. For centuries, lodestone was our only type of magnet.
Right. So this is the how the magnetic history is. So it is the history of magnetism. Later we'll discuss more. Right. So this is complete history how they got the stone by shepherd. Later they studied various ways. Even in the Egyptian times, the Greek time, they used to have the doors. Doors also, for closing the doors also, they used to have magnetite, with which if enemies attacks with the weapons, all the weapons are attracted towards the door. Such a wonderful effect they have seen. Then they finalized it as a ore of iron as magnetite, later named as magnet. Right? So hope you are clear about the what is magnet. Then there are two types of magnets are there, right? So one is natural magnet, other one is artificial or man-made magnets. So natural magnets are those which are available in nature, right? Like lodestone. Just know the shepherd catch that stone, which is called magnetite. The magnetite is the most important natural magnet, whereas other one is only earth. So there are only two natural magnets. If you ask for example of natural magnets, magnetite or lodestone, and second one is earth. Our earth is also a big magnet, spherical magnet. Okay. And these magnet, whereas artificially, if you see, based on the shape of the magnet we made, the name is given. It may be bar magnet in the shape of rod. It may be cylindrical magnet in the form of cylinder. It may be horseshoe magnet, U-shaped. It may be ring magnet, ring-shaped. It may be in the form of magnetic needle, just like a needle shape. And when the needle is placed in a box, it is called magnetic compass, which are used by the navigators to know the direction either on road or water or air. Everywhere this compass is helpful for showing the direction, because you know that magnet shows always north and south, points always towards north and south direction. Right? So this is we learned. Natural magnet, artificial magnet. Natural magnet are those which are occurring in nature, or which are available in nature, or which are found in nature, like magnetite or lodestone. Second one is earth. Whereas artificial magnets are those which are made by a man, by artificial means, as per our requirement. Wherever required, can battery magnets like electric bells, like motors, like washing machine, like electric bell. Everywhere we use the motor of different shapes. As per our requirement, we made the magnets into different shapes. That magnets are called artificial magnet. It can be in the shape of rod. It can be in the shape of cylinder. It can be in the shape of horseshoe, that is U shape. It can be in the shape of ring. It can be in the shape of needle. Right? Okay, then very interesting one. Magnetic materials, classification of materials. Suppose you can do experiment also. In front of you, you have so many things are there, like pencil, eraser, iron nail, right? You have the protractor, so many things in compass box, and paper, leaves, so many are there in front of you, right? You keep every material available in front of you and take a magnet and test it. Test with a magnet. This is done by the scientist during that time. All the materials available with us are tested with the magnet. Take one magnet and test them. What we observe is some of the materials are strongly attracted by magnet. Some of the materials are slightly attracted by magnet, whereas others are unaffected by magnet. Right? Unaffected. Based on that, based on the behavior in presence of magnet, all the materials are classified into, right? All the materials are classified into magnetic materials and non-magnetic materials. So magnetic materials and non-magnetic materials. So magnetic materials are those which are attracted by a magnet. Right? Non-magnetic materials are those which are not attracted by magnet. Clear? So whatever the materials you have, your water bottle is there, your pen is there, your pencil is there, maybe some your compass box is there. Test with all. Which are attracted, placed under magnetic materials. Which are not attracted, placed under non-magnetic materials. Right? So based on this again, the materials which are attracted towards magnet, out of that, some of them may be attract very strongly, some of them may attract very slightly. So based on that, these magnetic materials are further classified into paramagnetic, ferromagnetic, and diamagnetic substances. So both ferromagnetic and paramagnetic are magnetic materials. Diamagnetic is non-magnetic materials. So diamagnetic materials are those which are not attracted by magnet or repelled by a magnet. See here, copper, bismuth, water, gold. They are not at all affected by magnet. They are called diamagnetic substances. Next, para, substances which are weakly attracted. Weakly means slightly. We can call it as slightly, or you can call it as feebly also. Feebly is nothing but slight. Right? Slightly attracted by magnet. Or called, they are aluminum, manganese, chromium, platinum, all comes under paramagnetic. Whereas ferromagnetic substances, which are strongly attracted by a magnet, very strongly attracted, like iron, steel, nickel, cobalt, all these and their alloys will comes under. So all the materials are classified into magnetic and non-magnetic, which are further named as paramagnetic, ferromagnetic, and diamagnetic substances. Ferromagnetic substances are those which are strongly attracted by magnet. Paramagnetic substances are those which are weakly or slightly or feebly attracted by magnet, whereas diamagnetic substances are those which are unaffected by magnet or repelled by magnet. Right? So before going for the properties of magnet, so let me show you one video on the materials of the magnet, right? So how the magnet material is classified?
A magnet is a material or object that generates a magnetic field. This invisible force is responsible for the most remarkable property of magnets, their ability to attract or repel other magnetic materials. There are two main types of magnets: permanent magnets and electromagnets. Permanent magnets are objects made from materials that are naturally magnetized, or have been magnetized and retain their magnetic field even without an external field. On the other hand, electromagnets are created by wrapping a coil of wire around a ferromagnetic core, and passing an electric current through the wire. The current generates a magnetic field, but the magnetism disappears once the current is turned off. Magnetic field is produced in two ways: by the movement of electric charges, or by changing electric fields. The movement of charges could be the flow of electric current through a wire, the motion of electrons around a nucleus within an atom, or the spinning of electrons about its own axis. Every substance is composed of tiny units called atoms. Each atom has electrons, which carry electric charges. These electrons spin about their own axis, and revolve around the nucleus of the atom. The orbital motion of these electrons around the nucleus acts like a current loop, and causes each electron to act like a microscopic magnet, called magnetic moment. The spin motion also produces a magnetic field, and acts like a tiny magnet. In most materials, these little magnetic fields point in random directions and cancel each other out. But in some materials, like permanent magnets, the magnetic moments tend to line up, making a much stronger, overall magnetic field. To magnetize a material, we place it in a strong external magnetic field. This field exerts a force on the atomic magnetic moments, causing them to align in the direction of the external field. One end of the material becomes the North Pole, while the other end becomes the South Pole. In this way, a material becomes magnetized. The process by which a material becomes magnetized, acquiring magnetic properties, is called magnetization. When the external magnetic field is removed, most of the materials lose their magnetization, while some materials retain their magnetic field even after the removal of the external magnetic field. Material which can be easily magnetized and demagnetized are called soft magnetic material. Such materials are suitable for making the core of a transformer. While materials which are difficult to magnetize and demagnetized are called hard magnetic material. Such materials are suitable for making permanent magnets. Magnetic materials are classified based on their response to an external magnetic field. They can be categorized into three main types:
See.
ferromagnetic, paramagnetic, and diamagnetic. Ferromagnetic materials are strongly attracted to magnets. They can be permanently magnetized. Naturally, in a ferromagnetic material, the magnetic moments of individual atoms in a tiny region are all aligned in the same direction. The group of such atoms is called a domain. In an unmagnetized piece of iron, these domains are all pointing in random directions, so their magnetic fields cancel each other out. When a piece of iron is placed in an external field, all the domains are lined up in the same direction, so their magnetic fields add up and create a strong permanent magnetic field, and retain their magnetic properties even after the removal of the external magnetic field. Iron, nickel, cobalt, and their alloys are classic examples of ferromagnetic materials. Permanent magnets are made from ferromagnetic materials that have been treated to keep these tiny magnetic fields aligned. This is often done by exposing the material to a strong magnetic field during manufacturing. Neodymium magnets are currently the strongest type of permanent magnet commonly available. They are composed of neodymium, iron, and boron, and are widely used in various electronic devices, such as loudspeakers, electric motors, hard drives, and MRI machines. Paramagnetic materials are a class of materials that are weakly attracted to magnetic fields. Unlike ferromagnetic materials, which can become permanent magnets, paramagnetic materials lose their magnetism when the external field is removed.
They're not permanent.
Examples include aluminum, platinum, and oxygen. Diamagnetic materials are weakly repelled by magnetic fields. This repulsion arises from the way electrons within their atoms respond to an external magnetic field. Diamagnetic materials do not retain magnetic properties once the external field is removed. Common examples include copper, gold, and water. I hope this explanation helps you understand more about magnetic materials.
Right. So this is about the three types of magnetic material, how they classified based on their behavior in presence of magnet, right? The materials which are strongly attracted by magnet are called ferromagnetic materials, which are weakly attracted by magnet are called paramagnetic material, which are unaffected by magnet are called, or repelled by magnet are called diamagnetic material, right? Now, properties of magnet, next one. So when after getting that, just a minute. Just a minute. After receiving the material by shepherd, so they started studying how it is behaving. What is the behavior of the magnet in presence